Welcome back everybody to another exciting adventure of rational expressions. Today we're going to be adding and subtracting. So for adding, it's just like adding fractions. When we add fractions, we need common denominators. The bottom part needs to be the same. So if I have 1/4 plus 1/2, I gotta change the denominator. I need a common denominator, so I'm going to have to multiply top and bottom here by 2. So I get 1/4 plus 2/4, which gives me 3/4. If I have something like 7 over 4x plus 3 over 4x, the denominators are exactly the same. So my denominator is 4x. And I'm just going to look at this 7 and this 3 and add them together. 7 plus 3 is 10. If you can simplify it, simplify it. 2 goes into 10 and 4x, so this would be 5 over 2x. Not too bad, right? And third, we have 2x over x plus 6 minus 5 over x plus 6. And when we add and subtract, we just look at the denominators. X plus 6 is just x plus 6. Denominators stay the same because they are the same. And then we have 2x minus 5. We have to remember combine like terms. We can't do that, so we're just going to have 2x minus 5 here. All over x plus 6. Not terrible. So now we're actually going to be looking at kind of what we did yesterday with simplifying. But now we're going to combine with adding and subtracting. So now our fourth example, and we're still adding here. I have 7 over 9x squared plus x over 3x squared plus 3x. And right away we can see the 9x squared and 3x squared plus 3x are not common. So what we're going to have to do is factor. 7 over 9x squared stays the same, plus x. Always look for GCF first. I can take a 3x out of this thing. 3x, and then I'm left with x plus 1. And this is going to look kind of weird now. I need to see, hey, I need to get common denominators. So this 9x squared, I need to figure out I'm missing this x plus 1 here. Because really, 9x squared is just 3x times 3x. So the 3x is fine. I'm missing this x plus 1. So what I'm going to do is I'm going to do 7 over 9x squared. And I'm going to multiply the top and bottom here by x plus 1. Plus, I still have this x over 3x times x plus 1. And I have the x plus 1, I have this 3x, but I need to have a 9x squared. So what can I multiply 3x by to get 9x squared? Is 3x. So I'm going to multiply the top and bottom here by 3x. So I'm just going to multiply 7 times x plus 1. If I distribute that out, I get 7x plus 7 over, and I'm not going to worry about distributing the bottom at all. I'm just going to have 9x squared times x plus 1. Plus, I'm going to multiply here. X times 3x is 3x squared over 3x times 3x is 9x squared. And I solve this x plus 1. So now my denominators are exactly the same. So now I can just worry about combining the two numerators. 7x plus 7, 3x squared. I really don't have any like terms that I can combine. So if I put in standard form, 3x squared plus 7x plus 7 all over 9x squared times x plus 1. I know that it's a little confusing, but let's try some subtraction now. And it's almost exactly the same thing. This is example 5. If I have x plus 2 over 2x minus 2 minus negative 2x minus 1 over x squared minus 4x plus 3, I want to first see if I can factor, which I can. I have this x plus 2, this 2x minus 2, I can factor out of 2, and I'm left with x minus 1, minus, I can't really factor anything out here, so I still have negative 2x minus 1. I can factor this bottom, it's a perfect trinomial. Two numbers that multiply to 3, add to negative 4, x minus 1, x minus 3. So now I need common denominators. So kind of what I did with adding, I need to look and see. I have 2 and x minus 1 here. I have x minus 1 and x minus 3. So if I'm looking right here, they share an x minus 1. But what I'm missing is this 2 for this and x minus 3 here. So I'm going to take this x plus 2 over 2 times x minus 1. And what I'm missing is this x minus 3. So I'm going to multiply that. X minus 3 times x minus 3. Minus this negative 2x minus 1 over x minus 1 times x minus 3. And what I'm missing is this 2. So I'm going to multiply top and bottom here by 2. I'm going to have to FOIL at the top. And when I FOIL it, I wind up getting x squared minus x minus 6 over, I'm not going to worry about FOILing the bottom. I'm just going to have 2 times x minus 1 times x minus 3. Minus, distribute this 2 out, negative 2x times 2, negative 4x, negative 1 times 2, negative 2, over, again, don't worry about FOILing the bottom. I have 2 times x minus 1 times x minus 3, and now the denominators are exactly the same. So now I can combine this and say x squared minus x minus 6 minus this entire thing, negative 4x minus 2 over 2 times x minus 1 times x minus 3. If I distribute out the negative, I get x squared minus x minus 6 plus 4x plus 2 all over 2 times x minus 1 times x minus 3. And I'm going to erase a lot of this stuff, except for this last part right here, because I am running out of room. I wish I had my smart board so I could just press the extend page right now. Okay, so I'm going to rewrite that. I got x squared, and when I combine my terms, negative x and 4x is 3x, negative 6 and positive 2 is negative 4, all over 2 times x minus 1 times x minus 3. Now I'm going to erase this. And we always look, hey, can I simplify it further? Yeah, we can factor out this top part right here. Two numbers that multiply to negative 4 add up to negative 3. Or multiply to negative 4, add up to a positive 3. I have x plus 4 and x minus 1 over this entire thing, 2 times x minus 1, x minus 3. See if we can cancel anything out. Yeah, we can. I have the x minus 1 on top and bottom. Those can cancel out. And I'm left with x plus 4 over 2 times x minus 3. I know this is confusing. Please, please, please feel free to contact me with any questions that you may have regarding the homework. Next part of this, we're going to be looking at complex fractions.